Channel Maths and Methods Academy. In this video we are going to resolve given algebraic fractions into partial fractions. So let's get on with our solution. Our first question of this video is 3x plus 7 3x plus 7 over x plus 3 into x square plus 4 . Like always, we have to check the degree of the numerator and denominator. The degree of numerator should be lesser than the degree of the denominator, which is the same in this case, because the degree of numerator is 1 here and the degree of denominator is 3 here. How it is 3? Because if we multiply these two brackets, and when x multiplies with x square, we'll be getting x cube, so which shows that the degree of the denominator is 3. So now we can go ahead with we can go ahead in forming the partial fractions. The first factor, this one, it's a linear factor, which means we have to write it along with the constant in the numerator. This will be in the denominator and constant will be in the numerator. This one is quadratic factor, which means we have to write in the numerator one constant with the variable x and the other without any variable, and we will add both of them. This is how we will write. First one, we will write the linear factor partial fraction, which is a over x plus 3, and for quadratic one it will be x with b, and we will add c to it and then divide by x square plus 4. Now we will multiply both sides by x plus 3 into x square plus 4. X plus 3 into x square plus 4 into 3x plus 7 over x plus 3 into x square plus 4, x plus 3 into x square plus 4, a over x plus 3 plus bx plus c over x square plus 4. This will cancel with this and we are left with 3x plus 7 is equal to, and we multiply x plus 3 into x square plus 4 with both the terms that are there inside the bracket. So we are getting a into x square plus 4 plus bx plus c into x plus 3. We will call this equation as 1. Now we will assume different values of x to find the values of the constants a, b and c. First of all, we assume x as equal to minus 3. So the equation becomes 3 into minus 3 plus 7 is equal to a into minus 3 plus 4 plus b into minus 3 plus c into minus 3 plus 3. So 3 into minus 3 is minus 9 plus 7 is equal to a into 9 plus 4 plus minus 3b plus c into 0. So we have now minus 2 is equal to 13a. When we multiply 0 with minus 3b plus c, it becomes 0. So 13a is equal to minus 2. We divide both sides by 13. So our a is equal to minus 2 over 13. Now we have no other value of x which we could substitute in the equation number 1 to find out the values of constant b and c. So what we will do now, we will solve this equation and we will compare the coefficients of different degree of x on both sides in order to form equations and then solve them to get the values of b and c. Let's write down this equation one more time. So 3x plus 7 is equal to a into x square plus 4 plus bx plus c into x plus 3. We don't have the value of x square, so we'll write 0x squared plus 3x plus 7 is equal to ax squared plus 4a plus bx square when we multiply with this, and then we have to multiply with this one, so it will be 3bx. Now we multiply c with x and we multiply c with 3, so cx plus 3c. Now we will gather the terms with the same degree of x. So it is ax square plus bx square plus 3bx plus cx plus 4a plus 3c we have x square common here in the first two terms, and in the next two terms we have 3b plus c into x and then 4a plus 3c. Now we will compare the coefficients of x square. By doing that, we see that a plus b is equal to 0. We already have the value of a, which is minus 2 over 13. It gives our b is equal to 2 over 13. Now there is only one value left to be found, which is the value of constant c. So in this case what we will do, we will compare the coefficients of x, which are this one 3, we will be equal to this, so we write it down as 3b plus c is equal to 3. We have the value of b, which is 2 over 13. 3 into 2 over 13 plus c is equal to 3. 3 into 2 is 6 over 13 plus c is equal to 3. So c is equal to 3 minus 6 over 13. This is, here we will take LCM, so 13 into 3 is 39 minus 6, which gives us C as 33 over 13. Now we have all the values of constants a, b and c, so we can write our partial fraction. 3x plus 7 over x plus 3 into x squared plus 4 is equal to minus 2 over 13 over x plus 3 plus 2 over 13 x plus 33 over 13 over x squared plus 4. So this we can further solve. So minus 2 over 13 into x plus 3, and here we will take LCM of both the fractions, so it will be 2x plus 33 over x squared plus 4. So minus 2 over 13 into x plus 3 plus 2x plus 33 over x squared plus 4, and this will be multiplied with 13. And this is the answer of our question. Let's move on to our second question of this video. It is x squared over x plus 2 into x squared plus 4. Now I believe you will be very well versed in checking the degree. The degree of the the degree of the numerator is 2 here, and degree of the denominator is 3, which means it's a proper algebraic fraction. So we can go ahead with forming the partial fractions. So for this linear factor, we have to write only one constant in the numerator, and the linear factor itself will come in the denominator. Then second one is quadratic factor. Here we write two constants in the numerator with one of the constants multiplied with x. So we will write bx plus c over x squared plus 4 . Now we multiply both sides by x plus 2 into x squared plus 4. Okay, this one cancels with this one, and we are left with x squared is equal to, we'll multiply x plus 2 into x squared plus 4 with both the terms inside the bracket one by one. By doing so, we are getting a into x squared plus 4 plus bx plus c into x plus 2, and we will call this equation number 1. Now we will assume the value of x equal to minus 2 to find out one of the constants which are there. Those constants are a, b and c. So let x is equal to minus 2, and we'll place it in the equation. Minus 2 squared is equal to a into square of minus 2 plus 4 plus b into minus 2 plus c minus 2 plus 2. minus 2 square is 4, so a into 4 plus 4 plus minus 2b plus c into 0. So we are left with 4 is equal to 8a. We divide both sides by 8. So our a is equal to 1 over 2. Now we have no other value which we could assume in the equation to find out the values of the remaining two constants. So in this case we will solve the equation on both sides and then compare the coefficients of different degrees of x in order to form equations, and then solve those equations to get the values of b and c. So let's write our equation one more time. X squared is equal to a into x squared plus 4 plus bx plus c into x plus 2. Let's multiply it. Here we can write x squared plus 0x plus 0 because we don't have any term with the value with the variable x or any constant here. So it is ax squared plus 4a plus bx squared plus 2bx plus cx plus 2c. Now we will ax squared plus 4a plus now we have to group together the terms which are having the same degree of x. So it will be ax squared plus bx squared plus 2bx plus cx plus 4a plus 2c. So a plus b into x squared plus 2b plus c into x, and without x is 4a plus 2c. Now we will compare the coefficients of x square. Since x square is not having any coefficient, which means it has 1 here, so when we compare these two we will be getting a plus b is equal to 1. We have the value of a which is 1 over 2 plus b is equal to 1. So b is equal to 1 minus 1 over 2. So b is equal to 1 over 2. Now we have to find the value of c, and here we will be comparing the coefficients of x. The coefficient of x is 0 on the left side and on the right side is 2b plus c. This is the one. So 2b plus c is equal to 0. b is 1 over 2 plus c is equal to 0. 2 cancel with 2. So 1 plus c is equal to 0, which means c is equal to minus 1. Now we have found all the three constants a, b and c, so we can write our partial fractions. X squared over x plus 2 into x squared plus 4 is equal to 1 over 2 over x plus 2 plus 1 over 2x minus 1 over x squared plus 4. This will become 1 over 2 into x plus 2 plus, here we will take LCM 2, so x minus 2 over x squared plus 4 So 1 over 2 into x plus 2 plus x minus 2 into 2 over 2 into x squared plus 4, and this is the answer of our question. Now we move on to our third question. Third one is 1 over x cube plus 1. Obviously the degree of the numerator is lesser than the degree of denominator, so it is a proper algebraic fraction. However, we have a trick here. We have to factorize first the denominator of this fraction. The denominator is actually this formula. It's following this formula format: a cube plus b cube is equal to a plus b into a squared minus ab plus b squared. So using this formula we will break it down into 2. So it is 1 over x, one more step is there to make it more clear. It will be 1 over x cube plus 1 cube. Now let's follow this formula. First we will write a plus b means x plus 1, then square of a, which is x square, then we have to multiply x and 1, put a sign minus, and then square of 1, which is 1. So now we have got two factors in the denominator. One is linear factor and the second one is quadratic factor. And now we will be able to write in a similar way its partial fractions. How we will do it? 1 over x plus 1 x square minus x plus 1 is equal to, first one is linear, so it will be a over x plus 1. Second one is quadratic, so we will write x with one of the constants and we will add the other one to that, and then we will put over the quadratic expression whatever is there. Now we will multiply both sides by x plus 1 into x square minus x plus 1. X plus 1 into x squared minus x plus 1. 1 over x plus 1 into x squared minus x plus 1 equals to x plus 1 into x squared minus x plus 1 a over x plus 1 plus bx plus c over x squared minus x plus 1. This cancels with this and we are left with 1 on the left side, equals, we will multiply x plus 1 into x squared minus x plus 1 with both the terms inside the bracket, and we will be getting a into x squared minus x plus 1, and the other one is bx plus c into x plus 1. Let us call this equation as 1. Now now we will assume different values of x to find out the values of the constants a, b and c. So first of all we will assume it as 1 minus 1. By substituting minus 1 in the equation, it will look like a into minus 1 square into minus 1 plus 1 plus b into minus 1 plus c minus 1 plus 1. So a into 1 plus 1 plus 1 plus minus b plus c into 0. So this way we will be having 3a is equal to 1. 3a is equal to 1, and we will divide both sides by 3, which will give us a is equal to 1 over 3. Now we don't have any value of x which we can place in the equation to find out the value of the remaining two constants. So what we have to do here, we have to solve this equation and compare the coefficients of different degrees of x on both sides to form the equation, and then with the help of those equations we will find the values of constants b and c. So let's write the equation one more time. Ax squared minus ax plus a bx squared bx plus cx plus c Now we will gather different terms of the same degree of x. So it will be ax squared plus bx squared minus ax plus bx plus cx plus a plus c ax square minus ax plus a bx squared plus bx cx plus c. So then ax squared plus bx squared minus ax plus bx plus cx a plus c. Now we will here we can write 0x squared plus 0x plus 1. So a plus b, x square is common, then minus a plus b plus c, x is common, and in the last one without x it is a plus c. Now we compare the terms on both the sides which is not having x, which is this one. So a plus c is equal to 1. We have the value of a, which is 1 over 3. C is equal to 1 minus 1 over 3, which means C is equal to 2 over 3. And now we will compare the coefficients of x square on both sides, which are this one, which means a plus b is equal to 0. A is 1 over 3 plus b is equal to 0, which means b is equal to minus 1 over 3. We have found all the constants a, b and c. So now we can write our partial fractions. Partial fraction of the given algebraic fraction, it is equal to 1 over x cube plus 1 is equal to 1 over 3 over x plus 1 plus minus 1 over 3x plus 2 over 3 over x squared minus x plus 1. This is equal to 1 over 3 into x plus 1. Here we will take minus common. LCM will be 3, so we will have x minus 2 here over x squared minus x plus 1. So 1 over 3 into x plus 1 minus x minus 2 over 3 into x squared minus x plus 1, and this is the answer of this question. And with this we have reached the last question of our video. The last one is x squared plus 1 over x cube plus 1. In this question, denominator is again the same, so we can write factorize. Okay, first of all we'll check if the denominator, if the degree in denominator is, degree of x in denominator is greater than the degree of x in the numerator. Yes, it is. So it is a proper algebraic fraction, and in this algebraic fraction the denominator is again the same as we have seen in the previous question, which is x cube over 1, and this x cube over 1 we factorized with the help of this formula. Here we are going to do the same. X squared plus 1 over x cube plus 1 cube, which is equal to x squared plus 1 over x plus 1 x squared minus x plus 1. Now we will go ahead with the forming of partial fractions. So x squared plus 1 over x plus 1 into x squared minus x plus 1 is equal to, first we have this linear factor, so a over x plus 1, then we have quadratic factor which will be having two constants in its numerator, with one of them with x. Now we will multiply both sides by x plus 1 into x squared minus x plus 1. A over x plus 1 plus bx plus c over x squared minus x plus 1. This cancels with this, and we are left with x squared plus 1 is equal to we will multiply x plus 1 into x squared minus x plus 1 with both the terms that are there inside the bracket, and we will be getting a into x squared minus x plus 1 plus bx plus c into x plus 1. We call this equation as equation number 1. Here we will assume different values of x to find the values of constant a, b and c. So the first value that we will assume is minus 1, and we will be placing it in the equation. A into minus 1 squared minus minus 1 plus 1 plus b into minus 1 plus c minus 1 plus 1. We are getting here 1 plus 1, then a into 1 plus 1 plus 1 plus minus b plus c into 0. So 2 is equal to 3a plus minus b plus c into 0 is 0. And now we divide both sides by 3. So a is equal to 2 over 3. Now we will solve the equation because there is no other value of x that we can assume to find the value of the remaining constants, which are b and c. So let's write down the equation one more time. X square plus 1 is equal to a into x square minus x plus 1 plus bx plus c into x plus 1. Here we can write it like x squared plus 0x plus 1 because we don't have any x term. So we will write it as 0x. Ax squared minus ax plus a plus bx squared plus bx plus cx plus c. Now we will gather the value of the same degree of x. So ax squared plus bx squared plus, it is minus ax plus bx plus cx plus a plus c. X square is common in the first two terms, and in the next three terms x is common, and the last two are without x. Now we will compare the coefficients of x square. Since x square was having no coefficient, which means it is a 1, so it is 1, so we will be having a plus b is equal to 1. We know the value of a, which is 2 over 3. B is equal to 1 minus 2 over 3, which means b will come out to be 1 over 3. Now we will compare the coefficients of the terms on the both sides which are without x. These are this one, this one. So a plus c is equal to 1. We know the value of a, which is 2 over 3, plus c is equal to 1. So c is equal to 1 minus 2 over 3, which means the value of c is equal to 1 over 3. Now we have figured out all the three constants, that is a, b and c, so we can write the partial fraction now. So x squared plus 1 over x cube plus 1 is equal to 2 over 3 over x plus 1 over 3x plus 1 over 3 over x squared minus x plus 1. Let us solve it further. So this is the final answer of the question, and that's all for now. Please don't forget to subscribe the channel, and until the next time, take care and bye.